Okay. All right. So just a reminder then that we are learning about the names of things. And imagine, going to the zoo. You want to know the names of the animals you're looking at. And they also have the scientific names there. And you may or may not pay any attention to that, but they're there. And anybody in any language can use those scientific Latin names um, to talk about the same species, and everyone should understand that. Of course, that's only if you learn the names. So it's a similar thing here. If you want to communicate to anybody about molecules and ions and that sort of thing around the world, you do have to know the names. Then, of course, the next step is speaking intelligently about them, what they do, and that sort of thing. But we kind of have to know what they are first. Before we can talk about what a zebra does, we have to know what a zebra is, all right? So, for instance, a zebra. Zebra is white with black stripes or black with white stripes? I heard one answer in the classroom. Any others?
It's white with black stripes.
Oh, I heard the opposite answer on the Zoom.
I think that it's black with white stripes.
I heard an alternative. Would you repeat that? Pink with black and white stripes. Have you ever seen a shaved zebra? No, why would you? It'd probably be animal abuse. But uh, if you do, you'll find perhaps a surprising color there. I do lean towards the black with white stripes crowd for the portions of its skin that are not covered by hair, but
Snout.
yeah, the snout. But it's debated. It's debated, and so that's what we want to do. But you first have to know that there is such a thing as a zebra, and you have to know that there is such a thing as phosphate, and that sort of thing. So, all right. So that's what we're doing is we're learning the names of the things so that then we can speak intelligently about them later on. All right. So here's the slide we're on. Okay. So. I think everyone should know this answer fairly quickly. Just go ahead and say it out loud. Do metals or nonmetals tend to form cations? Which one of those two? No, it's not a yes or no question. It's an either or question. Metals or nonmetals?
Oh,
Metals.
non-metals, right?
Metals will make cations. Okay, metals will form cations. Metals are the things on the left of the periodic table, and nonmetals are the very few elements on the right. And anions are made from nonmetals. Excuse me?
So how do you split the periodic table?
With scissors.
That's how I meant, like.
Oh, okay.
The left and right.
Oh, good question. Okay, so how do you know what the left and the right are? So remember that there are four parts to, there are four different types of orbitals, all right, four different subshells. There's the S, the P, the D, and the F, okay? Three of those are just metals. S, P, and D are just metals, except for hydrogen. But it's debated, should hydrogen be in group 1 anyway? Some people put it in group 17. But in any case, all three of those are purely metals, especially D and F, but also S, except for hydrogen. Now the only thing then is P. That's the only one that is divided there between metals and nonmetals, and it's got the metalloid gash going right through it, the metalloid scar, to separate those two types of atoms. So remember what causes nonmetals to be nonmetals isn't something mystical. It is simply the attraction between the nucleus and more electrons. These nonmetals would like to have more electrons than they started off with. They're okay with that. The metals, on the other hand, have a few too many compared to what they would like to have. And so the vast majority of different kinds of nuclei will attract a lot of different, arrangements of electrons. Most of them will be too much for the nucleus to really hold on to, and they're metals. But there are a very few that want more. And then we generally put the noble gases in the nonmetals because they're not metals. But they're completely satisfied and they do nothing whatsoever, except if you strong-arm xenon, you can make it react a little bit, and krypton too. But pretty much helium and neon and argon truly do nothing. So the only stuff that isn't a metal that does react is like 10 to 15 elements. So that's how you split the periodic table. So there's a stair step over here. That on this one behind me is light blue. In the classroom is a darker blue. But that pattern there is the wall or the no man's land between those two types of elements. Does that help?
Yeah.
Okay. So sometimes I forget that not everybody has this, memorized by heart for years and years and years. So please do stop me if I just presume that you know exactly what I'm saying. So do make me clarify things anytime I need to. So cations are going to be positive, and that's because they have a few too many electrons, so they go ahead and get rid of them very easily. Anions will be negative, and that's because the atomic radius is small enough it can fit a few more around and hold on to them. That's why we also looked at the trends for radius and stuff. Questions from those at a distance? Okay, all right, so there you go. Suppose you were trying to teach someone how to name ions. Okay, now we're not going to do like Bob and Larry and that sort of thing. Which rules about the language of chemistry would you emphasize? All right, go ahead and you can discuss amongst yourselves. Again, I'm not saying, section 2, article 8 or anything like that. I'm saying, just how do you name things in general, especially in chemistry? What would you want to emphasize? Okay, maybe it's a stretch to suppose that you would be.
Interruption. We are so sorry. We know that the Wi-Fi is still down and having issues. We will update you when we know the progress of what's going on with it. Thank you.
How are you on Wi-Fi?
It's hardwired. The old way. All right, now I know somebody sent something to the chat box, but unfortunately when I'm sharing a screen, my chat box has disappeared. So I used to be able to see it, but no longer. So sorry, your message has been lost. It's there. When I stop sharing at the end of this class, then I will see your message, but by then it will do no good. So if it's something you'd like to say out loud, please unmute yourself.
Isn't there like an octa rule or something like that?
Isn't there a what?
Like an 8 rule.
All right, yes, the octet rule. Octet. We do want to make sure that there are 8 electrons around on the valence level, the outside layer of an atom. Don't really want to fit more than that on the outside layer. Oddly enough, although the outside is, by definition the biggest for surface area, once we start filling in like the D block, we're filling in more underneath, and so we can fill a total of 18. Now, once we get zinc, we've got we've got 18 electrons on the third energy level. So it's not that you can't fit more than 8 on a level. It's just you can't fit more than 8 on the outermost layer. So maybe that'll come in to our naming ideas. Other ideas? Okay, let's see here. So we want to have the word ion or cation. So for instance, aluminum ion or silver ion or something like that. If there's more than one cation, we want to add a Roman numeral in parentheses. Again, no space between the parentheses and the name of the element, the English name of the element. And if we have anions, we want to start with the stem and end in "ide." You guys remember that from yesterday? All right, so sulfur becomes sulfide.
I wasn't sure.
Excuse me?
I said, yeah, I was going to say that, but I wasn't quite sure about it.
Okay, all right. No problem, no problem. Maybe you were thinking of like grander things and thought these rules were so basic and you didn't want to say them. But this is what we're driving at here is if it's going to be positive, blank ion. If it's going to be negative, blank ide. And that's if it's monatomic. All right, let's keep going. Polyatomic. Yay! It gets more, it's like binomials and then going into polynomials. All right, everybody loves those words? Poly. All right. How do polyatomic ions differ from monatomic ions? How are they similar? All right, what is the first thing, knowing by the Greek prefix, what's the first thing that's definitely going to be different about polyatomic ions? Say again? When they have shapes? Well, they will have shapes. I mean, the monatomic ions will have shapes like kind of like spheres. But yes, we will have to consider the geometry and the shape of them. And why do we have to consider those things, Gavin? Why might we have to consider the shape of polyatomic ion? Like, what's going on that makes them have to have a shape?
It's a poly.
Right, what does poly mean? Okay, well, I'm not asking for like a strict dictionary definition, but like if I was to use an English word, Nevaeh, what would I say? Those of you at home, poly?
Many.
Would it be multiple?
Many, multiple, yes, more than one. Many more, multiple, more than one, right. That's what poly means. So, just like a polygon or a polyhedron, a polyone cracker. All right, so now how are they similar though? Well, then we go to the second word. Well, not the second part of the first word, but the second word.
Oh, ions.
Ions, right. Okay, so they overall they're going to have an ionic charge. They're going to be like a magnet stuck to other ions. They're not going to be like molecules that kind of have London forces and van der Waals attractions and that sort of thing. They are going to have a very strong ionic bond with things. So, more than one atom, but it will have a charge. Okay, so sulfate, very, very, very famous, useful ion is sulfate. You'll find it in a lot of foods. Too much is no good for you, but then too much of anything is bad for you. Even oxygen will kill you. So, say again. Oh, okay. Ah, yes. Too much oxygen will kill you too. Yeah. Yep. Too much of anything. The poison is in the dose, is what Paracelsus said. So, there's a Queen song about that too. So, now the sulfate anion has one sulfur atom and 4 oxygen atoms. Don't worry right yet how they go together, except I'll just say that it's similar to tetrahedral, and not exactly tetrahedral, but the sulfur is in the middle and the 4 oxygens go off from it. You don't really ever have an oxygen bound to another oxygen. They don't like each other, so that doesn't happen much. So you have one sulfur in the middle and 4 oxygens around it. Altogether, they have they just have one overall charge, one overall 2- charge. And so that formula is written SO4 2-. And if you're just typing it out, in regular text, like on a Google form or something, you would have SO, they're both capitals, of course, 4, and then in parentheses put 2 minus. That parentheses tells me then that's kind of the overall thing. It's not that the oxygens are 2 minus or the sulfur is 2 minus. The whole thing is 2 minus. When you study the structure of it, you'll find that 2 of the oxygens are completely normal, and then the other 2, each of them has a -1 charge, but we're not there yet. Questions about sulfate? You will need to memorize what sulfate is, that it is a sulfur, 4 oxygens, and has a -2 charge, a 2 minus charge, I should say. You do need to know how to write it, and you don't need to know how to format it necessarily with subscripts and superscripts, but you do need to know what it is, and we'll get into what it does later on, but you got to know that there is a zebra before you know the behavior of the zebra. All right, so here's some pictures. Here's your sulfate ion, and like I said, that yellow in the middle is sulfur, and 4, kind of like a clown, 4 red lobes coming out of it. And then you see a lot of these have oxygens stuck around them because there's a lot of oxygen on Earth. And so we have nitrate, sulfate, phosphate, 888, because they're chock full of element 8. That's not why it's called that, but that's how I remember it. Okay, so if it's as full of oxygen as it can be, it ends with 8. Ends with 8. And this is kind of like ick and us, like ferric and ferrous. Even though we don't do that for the ions anymore, we do it when it comes time for acids, and we'll get to acids in a later chapter. But nitrate, you have a lot of those in your foods, especially hot dogs are famous for those. Phosphates, you have a lot of that in your sodas. Phosphoric acid is in your sodas, and that helps to make it a nice soury, lemony flavor. It's not citric acid, but it fools the mind. Ammonium, on the other hand, over here, has one central atom, which is nitrogen. Nitrogen is traditionally blue. Oxygen red, sulfur yellow, and hydrogen white. And so there you see here, these are all ions, but they all have covalent bonds within themselves, and they're quite happy having the extra charge left over. So ammonium nitrate is something you can actually buy to help your plants grow. It is plant food. You put them together. Ammonium sulfate you can also get. Don't know that you'd want that on your plants so much. I haven't really studied it. Ammonium phosphate, all these things. Now, nitrates and phosphates, they also make very good, I better watch what I say or else YouTube will flag this. They make things that were historically very dangerous. I'll just say this. And there's a lot of energy in these. I keep wanting to say molecules, but these polyatomic ions. They're not exactly molecules because they do have a charge. So you'll see here the charge. There's positive, 1 negative, 2 negative, 3 negative. And again, these are just things that you do have to memorize. After a while, you'll see a pattern, but it's not obvious at first. I'm going to go ahead and wrap it up there with a list of some other very common polyatomic ions. And you'll see you'll have some charges here. Notice you don't really ever get to -4, and so your run-of-the-mill polyatomic ions are -1, -2. Very few polyatomic positive ions. Very few of those. There's ammonium, there's hydronium, I've talked about before, and that's about it for your typical positive ones. Typically, if you want a positive ion, you just get a metal. Get a metal, and it's really easy. So your nonmetals tend to do the covalent bonding anyway, and so they tend to make the polyatomic anions. All right, and that is where we'll pick up again on Monday, and I hope that you have a good, safe weekend. Thank you for coming. I'll stop the recording now.